Math 2, section 4.3, bisectors and triangles. So we are going to look at a couple different theorems. I said this earlier, but we have that sheet where we're going to kind of write all of our definitions and pictures on it, but we're going to do it during our notes tomorrow, okay? So the first thing we're looking at is concurrency of perpendicular bisectors. Now, what does concurrency mean? Can you guys find that word in the set of notes somewhere? Good, and you might want to underline or highlight it, but concurrency means when there are 3 or more lines intersecting at one point, they are concurrent. Okay, and the specific point is the point of concurrency, is where they actually intersect. So the lines are concurrent, and then the point is the point of currency. Okay, so here you have perpendicular bisector theorem. Okay, what that means is that you end up drawing a line that bisects the sides. Okay, when it bisects the two sides, it makes two equal parts, and then since it's a perpendicular bisector, it makes a 90 degree. You guys with me on this? Okay, so like on this line over here, 90 degree angle, it makes those two equal. Over here you have a 90 degree angle, and those three dashes mean those sides are equal. Now that point right there where those intersect is specifically called the circumcenter. So we're going to write that. Now, they gave the circumcenter point P. Okay? What ends up happening is that each of these lengths from P to the side will all end up being equal. Now, actually from the vertices. So see how B to that vertice P, that will be equal, this will be equal, and this will be equal. Do these lines right here look like they'll be equal? No, probably not. There's a chance, but it's specifically from your vertices. Okay, those will all be equal. Okay, this was on page 215. We're going to move on and look at the next one. Okay, on page 216, there is a proof to show why those are equal. We are not going to work through it right now, but you know that it exists and you can look through that later. This next part here on page 216, I want you to look at it. So there are 3 different types of triangles, right? We have an acute triangle, a right triangle, and an obtuse triangle. Are we focused, guys? Yeah? Okay. So an acute triangle, you'll notice that the circumcenter is inside the triangle. Okay? And the circumcenter is, when you're cutting these lines in half, it's the point that they all intersect in the middle. On the right triangle, when they cut each of these sides in half, the circumcenter, if you notice, it is right on that side. What is that side called? And I'm actually going to write this right here. So this one was on the inside. This one is on the hypotenuse. And you're going to be right. I would write these things in your book. And where is it on the obtuse triangle? It is on the outside. Now, specifically on the hypotenuse, it is the midpoint, because you know how you are cutting the hypotenuse in half to make this, so this is equal to this. And so the circumcenter is specifically the midpoint of the hypotenuse. Okay, so it's important to remember that on that triangle, and that will help you on right triangles, will help you with your homework tonight. Okay, does everybody have this? Yes? Wait a minute. We're good? All right, turn to page 218 now. So I want you to look at that figure. So in this city planning, they want to place a recycling barrel so that it's equidistant. And what does equidistant mean? Equal distance from the lifeguard chair, the snack bar, and also the volleyball courts. Okay? So based on that information and what we've been learning about perpendicular bisectors, where do you think that that trash can or recycling bin should be placed? So talk in your group. See if you guys can think about it. If you're not sure, draw bisecting lines through each of the sides and see what happens. Okay, so what do you guys think? Do you guys talk about it in your group? Where do you think that the barrel would be put? Very good. The midpoint of the hypotenuse is correct. If you were to cut this line in half right here, it'd be about right there, if you could draw better than me. This line in half should be about there. And then we know this one in half has to be right in the middle there. So remember, on all right triangles, it is what? The midpoint of the hypotenuse. So I'm just going to write here, midpoint of the hypotenuse. And so that will be equal distance from each of these areas. Okay? All right. So now we're going to move on here to page 218, or at the bottom of 218. And we have concurrency of angle bisector theorem. What is angle bisector talking about? Bisecting angles. So it's not bisecting the sides, it's bisecting the angles. And so when you look through here, do you see how this one bisected this angle? And so it has the 2 hash marks, this one has 1 hash mark, and this one has 2. Okay, this point in here is the in center, is what it's called. So the point of intersection is the in center. Now, if I were to draw a line and like this inside my triangle, if you were to draw a perpendicular line from the in center down to each of the sides, each of these lengths will be equal. And this is called an in center because we can make a circle. You can think of it as a circle in the center of the triangle. Okay? So your angle bisector makes an in center point, where if you were to draw a circle inside there, each of these distances would be equal. Okay? And that's what it's explaining right down here. All right, moving on. Go to page 219. Okay, so based on what we just learned, okay, here it's saying that QN is this, and QM right here is that. And we just learned that those lines, so you notice how they're making perpendicular, they're making 90-degree angles, okay? That these two, this is one of your in centers, because see how it's doing an angle bisector? Do I see that? That point right there is the in center, which means that each of these lines coming off that make 90-degree lines, those are equal. So what would I do to solve for x? Good. 5x plus 36 equals 2x plus 51. I'm going to give you a minute to solve for x and tell me your answer for x on your hands. Good. 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 You got it. Good. Good, Stephen. No. Okay, so I would subtract 2x to both sides. Are you okay with me subtracting 36 to the other side at the same time? So that cancels that, so I'm getting all my letters together, all my numbers together. I get 3x equals, and 51 minus 36 is, I have to borrow, and we get 15. Divide by 3 to both sides, x equals 5. But is that what they asked me for? No, they wanted to know the length of what? QO, and QO is right here. But what do we know about all of these lines? They're all the same. So does it matter which one I plug x in for? No. I think this one looks easier for QM. So I'm going to go 2 times 5 plus 51. I get 10 plus 51, which is 61. So that means QO equals 61. Okay, so B, reasoning. Is it possible for QP, so QP is right here, okay, to be equal to 50? And explain. So in your groups, I'm just going to give you like less than a minute. What do you think? Do you think it could equal 50, or do you think it has to be more than 50, or it has to be less than 50, and why? So kind of talk about it real quick. All right, so what do you think? Yes or no? No is correct. Why? Madison, why? Shh.
The small triangle created, the right triangle created by Q and P. And we already know that QN is 61. And if you look, QP is the hypotenuse, so it has to be larger than 61.
I like that reason. I didn't even think about that. Did you guys hear what she said though? So we already know, okay, no, because we know that QN equals 61. Isn't that correct? And if you look here, Madison was saying that this is a 90-degree angle, and across from your 90-degree angle is your what? Hypotenuse. And your hypotenuse is always the largest or longest side. So therefore, okay, QP has to be greater than 61. Okay? So since QN is 61, we know that QP has to be greater than 61. And specifically because it is the hypotenuse. Okay? All right, moving on. It's just or works for you. All right. Page 219, still look at number 4. Okay, so your point of concurrency is where lines meet by using our angle bisector or our side bisector, our perpendicular bisector, right? So perpendicular bisector or angle bisector. Can you guys find the point where two lines at least bisect from the angles? Because this is dealing with angle bisectors, right? So where do the angle bisectors meet? And if you need to, highlight the lines that we're looking at, because they threw in an altitude there to confuse you. Because the altitude, this is not an angle bisector, is it? So what point do they intersect at? Z. So Z is our point of concurrency. Okay. Number 5. Find the value of X. How will I do that? What will I do to set up my equation? So they have RS here and they have RT here. Do you see how highlighting things sometimes kind of helps me to see it? So we know that these two lines are actually equal to each other. And so you'd set those equations equal to each other. Show me on your hands once you get the answer. Good. Good. Oh, no, sorry. Yes. Good. Good. Yes. Good, good, good. No. Good, no. Good, good, good. Yes. There you go. Did you actually get that? Okay, so the correct answer was 4. You should have set those equations equal to each other. And so in order to solve, we would distribute through here. 4 times x is 4x. 4 times negative 3 is negative 12 plus 6. Here we distribute and we get 10x minus 30. Okay, you combine like terms. Negative 12 and 6 makes what? Negative 6 equals 10x minus 30. And then we have to solve for x. And so I'm going to subtract 4x to both sides. At the same time, I'm going to add 30 to both sides. Negative 6 and 30 makes 24. And 10 minus 4 is, and we divide by 6 to both sides and get x equals 4. Okay, questions there? No? Does anybody need this up still? Did we see where we went wrong, some of you? Yeah. Okay. Now turn to page 220. We're going to try a couple more problems on your own. We're going to do problems 7 through 9 on page 220. So look at number 7. Okay, so in this figure they tell you that TV, so here's TV, I might highlight it in my book. TV is 3x minus 12, and then you have TU is 5x minus 24, and they want to know the value of x. So once you get your answers, you can show me on your hands. Yes, yes, yes. Good, 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 good. There you go. Yeah, yep. Perfect. Good, 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 good. Good, good. You got it, Josh. Good. Got it, Josh. Good. Good. Perfect. Good. Good. Okay, so the correct answer was 6. So in order to solve number 7, you are just setting the two equations equal to each other. 3x minus 12 equals 5x minus 24. Okay, and so here, subtract 3x to both sides. Those cancel, add 24 to both sides. And we get 12 equals 2x, which means that x equals 6. Okay, number 8. Okay, a triangle's circumcenter is outside the triangle. What type of triangle is it? So we're going to do it like this. Acute is 1, obtuse is 2. Oh no, acute is 1, right is 2, obtuse is 3. So which one is right? Good, 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 good. Okay, so the correct answer is obtuse. So number 8, it was an obtuse triangle. Okay, and then number 9. So you have to think about this one. I'll read it out loud, and then I want you to talk in your groups, and then we'll share out. So you want to find the circumcenter of a triangle. Why do you only need to find the intersection of 2 of the triangle's perpendicular bisectors instead of all 3? Okay, so talk in your groups. Why do you think you only need to do 2 even though there's 3? Okay, so can anyone share out and try to explain why on number 9? Madison, go for it.
Since 2 lines are, we know intersect at that point, they're not going to intersect again. So we can logically decide that the 3rd line will also intersect again too.
Exactly. So does that make sense? So if we know that all 3 lines intersect at the same point, then that means that if 2 lines are intersecting, that's going to be the same point as it would hit if there were 3. Yes? Now, the way that I wrote it, and I don't know if this will make sense to you or not, but if you want to write this down, you can, is that since the 3 perpendicular bisectors of a triangle are concurrent, and what does concurrent mean? Meet at the same point. The 3rd perpendicular bisector will go through the same point of intersection as the other 2 perpendicular bisectors. All right, so once you have that, I'd like you to get out worksheet number 3, and we're just going to look at a couple of the problems. Again, you're only doing the even problems on worksheet 3, and I'm going to keep recording because I think that this will be helpful if you needed to go back and look at this. So I want to look at number 2 on worksheet 3. Oh, wait. So some of you are still writing, so I'm just going to wait a minute till you're done. Okay. All right, so worksheet 3. Look at number 2. Okay. So it says find the coordinates of the circumcenter of each triangle. So first of all, when you look at number 1, for instance, what type of triangle is that? A right triangle. And where would the circumcenter be on a right triangle? The midpoint of the hypotenuse. Okay, so looking at number 1 first, where do you see where would be the midpoint be on the hypotenuse? Can you kind of tell? If you can't tell, all you're doing for perpendicular bisectors is doing the midpoint of each of these lines. So remember how if I were to take 2 different lines, I know that it's the same point as all 3. So see how it's easy to intersect here, right? That's going to make a perpendicular bisector right there. And then on this side, I would make it in between these 2 lines, right? So it's going to be the midpoint on this one is going to be about right here. And I draw that line. And so with having these 2 midpoints, I found the perpendicular bisector on my hypotenuse over there. And what would that one be as an ordered pair, even though you don't have to do this one? So it goes over 2. And then it goes up 1, 2.5. So you write that as 2.5 or 2.5. Okay, so on number 2, you could kind of do this same exact thing, right? You can draw 2 perpendicular bisectors, or which side is the hypotenuse? Do you know? This horizontal line, right? And so this is the hypotenuse, and if I cut that in half right there, we can see that the point, this would end up being my circumcenter. And what ordered pair is that? 1, 3 is correct. Now, I want to show you, so we're looking at this visually, but do you know how to find the midpoint algebraically? Okay, so the midpoint algebraically, your midpoint theorem, I don't know if you guys remember, is where you're going like x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So that also gives you your midpoint. So I'd like us to use these 2 points and use the midpoint theorem to find the point of intersection, okay? And so this ordered pair right here is what? -2, 3. And then this point over here is at 4, 3. Is everybody okay with that? And when you write your ordered pairs, they actually line up with your x's together. Do you guys see that? And your y's together. And so to find the midpoint, you add these together and divide by 2. You don't even always have to like write it out if you have the points written out, but we'll write it out just for fun. And so that means I have -2 plus 4 divided by 2. What is -2 plus 4? 2. And 2 divided by 2 equals what? 1. So the midpoint will be 1 for the x value. And then I add the y values together. 3 plus 3 divided by 2. 6 divided by 2 is 3. So do you see how I can find the answer mathematically or algebraically, as well as looking at the graph and finding the point there? So we got the same point either way that we did it. Now, when you're doing your homework, as you go down, like for 4 and 6, you might want to have graph paper. So I have graph paper in here if you want to take some, or you can draw your own graphs. But you basically need to figure out which 2 points make the hypotenuse, right? So you have to figure that out on your own. I'd like you to switch over to the next page now. And this, numbers 10 through 13, they're just asking you to name the point of concurrency of the angle bisectors. So when you look at those, you need to look at the 2 lines that are the angle bisectors. And so like I said, it makes a lot more sense to like highlight your lines that are the angle bisectors. So I know this one's an angle bisector because see how it has 2 dash marks? Okay? And then over here, B, I know this is an angle bisector because it has the 1 arc mark there. And do you see what point the 2 lines intersect at? Q. Because do we need all 3 lines on there? No, we learned that we only need 2 because all 3 end up being at the same point. So if you have 2 at one point, you know the third one's also going to go through that point. Okay, could you guys do 11? Even though you don't have to for your homework, you can still do it right now. So what would be the point of concurrency here? Good. Hopefully you said U. And again, if you look at this, if you highlight where the angle bisectors are coming from, you can see they actually intersect at point U.